Hello guys, welcome to Ramta Solutions. Today in our lesson or our example on sequences and series, we're looking at this series here. It says 7p to the 8 times k to the 15 plus 20, p to the 9 times k to the 14 plus 23, p to the 10, k to the 13 plus and so on until 53, p to the 20, k to the 3. Write this in sigma notation. I want you to see a pattern here. I want you to see a pattern here. We have a pattern of constants. Now the constants are 17, 20, 23, and so on. And the last term is 53. Okay, these are for constants. Okay, these are for constants. Now for the p's, I want you to notice that we have p to the 8 plus p to the 9 plus p to the 10 and so on until p to the 20. Okay? Until p to the 20. For the case, we have k to the 15 plus k to the 14 plus k to the 13 plus and so on until k to the 3. All right. So as you look at these, you can see that there is a pattern somehow. Can you see that? You can see that there is a pattern somehow. By inspection, you can basically guess what the general term for each pattern here is. Okay? You can guess what the general term for each pattern is. For example, for the constants, you have Tn equals, it looks like 3n plus 14. Like it looks like it is 3n plus 14. While for these guys here, it looks like it is n plus, I think it looks like it's n plus 7. While for this one here, it looks like it is minus n plus 16. Right? It looks like it is minus n plus 16. Do you see that? You can guess what the general term is, but I don't want us to guess. Let's just work it out. Okay? So maybe let me just write it. So here I'm saying we might find 3n plus 14, while here we will find n plus 7, and this will be minus n. This will be minus n plus 16. Okay, this will be minus n plus 16. Okay, so let's just prove that indeed we get this. And also, because the intention here is to write in sigma notation, we need to know where we start counting and where we ending. Okay, perfect. So for the first one, which was 17 plus 20 plus let me say constants first. For constant, we have 17 plus 20 plus 23 plus and so on until 53. So what is this? Obviously, our A is 17, and it looks like our common difference is 3. So the general term here would be A plus n minus 1 times d, which is 17 plus n minus 1 times 3, which is 3n plus 14. Indeed, 3n plus 14, right? Now, for the p's, we had p to the 8 plus p to the 9 plus p to the 10 and so on until p to the 20. For this, it looks like we have, I want you to just consider the exponent only. So it looks like our first term is, let's say, 8. Okay, just consider the exponent only, 8, and the difference, common difference is 1, right? So we can say T sub n is what? A plus n minus 1 times D, which is 8 plus n minus 1 times 1. This looks like it is n plus 7. Let's confirm. Indeed, it's n plus 7. Again, maybe it can help us to find the number of terms. Let's find the number of terms. So the number of terms on this thing here, the number of terms here would be, what is the last number here? This was, oh, it was 20 years. It was 20 minus, what was the first? The first was 8 plus 1. All right, so what is this? This is 13. So it means this sequence, has 30, or rather this series has 13 terms. All right, I prefer to use 1 for the p's because it wasn't that complicated as compared to for the constants. For the constants, I'll have to say Tn equals 53 and solve for n. It's a long process for now, so we don't want to do that. We want to save time in the exam, right? So the number of terms here are 13. Now let's look at the k. So for the k, we have, looking at the exponents rather, we have 15 plus 14 plus 13 plus and so on until 3, right? So as you can see, the first term is 15. The common difference here, it looks like it is minus 1, right? It is minus 1. So T sub n is A plus n minus 1 times D, which is 15 plus n into n minus 1 times minus 1. And this is minus n plus 16. Let's confirm it. Indeed, it is minus n plus 16. Okay? So we have said this is equal, has 13 terms. And with the 13 terms, using the general terms that we just derived now, we can say we start counting from 1. Okay? We start counting from 1. So the sigma notation will be, therefore, this will be from 1. So let me just say n equals 1, and we end at 13. And the general term for the constants was 3n plus 4. 3n plus 4, was it plus 4? Plus 14, sorry. Yes, it was plus 14. 3n plus 14. Right, it was 3n plus 14. Okay, it was 3n plus 14. What am I doing? 3n plus 14. And we're moving on to the p. The p had the power n plus 7. N plus 7. And then we move to the k. The k's have the power negative n plus 16. And this is the sigma notation of that series. Okay? This is the sigma notation of this series. Okay? So if you want to prove, let's maybe try to prove with the term 3. Okay? I will prove with term 3. So where there's n, I will put 3. So it'll be, where is it? Where there's n, I will put 3. Maybe I can just squeeze it here. Where there's n, I will put 3. It'll be 3 into 3 plus 14. P to the 3 plus 7. K to the minus 3 plus 16. This looks like it'll be 9 plus 14. 9 plus 14 will be 23. 3 plus 7 will be 10. minus 3 plus 16 will be 13. So please go check the third term on the series. The third term on the series, where is it? Here is it. Can you see that? This is the third term on the series. Indeed, it is what we got. So this means our sigma notation is correct. Okay, this means our sigma notation is correct. You can choose whichever term you want to prove your sigma with, or your sigma notation with. Okay, so this is how you do it, guys. Okay, this is how you do it. So, all right, and I will see you next time. And it's bye-bye. Okay, it's bye-bye. Let me erase this so I can leave you with the final answer. So, bye.